next week is the final exam week. So we still have class. We don't have final exam. So please still come to the class. Next, Tuesday. Okay. So today we have a piezoresistive sensing device. For example, we have this circuit. Then we put our piezo resistor here and here. We keep these two resistors constant. And we use this circuit to change the resistance change into frequency output. So we can read frequency output to measure the resistance change. And the resistance change depends on the stress, pressure we applied to the piezo resistor. So in reality, this is a pressure or force or stress variation into frequency variation device. And Ethan, did I teach you in this class, this one? Leo? Or Marsden? Yes, we did. Okay. And we have been through this one once. But now we modify our device. We say we put this R1 as Rn plus delta R, and this R2 as Rn minus delta R. So it's a differential device. Then R3 equal Rn, R4 equal to Rn. So now we have, this is VO plus, VO minus. VO plus goes to this instrumental amplifier. And VO minus goes to this negative side. So this goes to positive, go to negative. And IA, we get VIA, the output of the instrumental amplifier, because the voltage difference is very small. So we need the amplifier to amplify this output signal. After that, we go through the integrator. We can get charge up and charge down due to this charging, discharging process of the integrator. We have this zero crossing detector to trigger this one-shot vibrator to provide the frequency signal. And the frequency signal, we have this output signal can switch this device to make RO in parallel with R3 or in parallel with R4. So this is the timing diagram. See the output. In the high level, we go charge. And if the output goes to the low level, we go to discharge. So charge, discharge. Then if we go through this zero crossing detector, we will trigger this vibrator to provide a vibration with fixed amplitude. But if R1, R2 varies, then the level of delta V1, delta V2 will be different. Then the charge discharge time will be different. Then this period T will be different. So by detecting this period variation, which is frequency variation, we can detect the resistance variation. We have derived equation for only R1 variation, but now we have two resistors variation. So please look at these equations and derive this one. For this case, if we do the two resistor variation, delta, the sensitivity is twice as the previous case. For the previous case, SR is 1/2 times 1 plus 2R0 divided by Rn. Only one resistor variation. But for this case, we don't have divided by 2. You have this one. So the sensitivity doubles for this arrangement. Okay, now get your pen and your paper. Please go through these derivations and convince yourself the sensitivity is this one. Okay, camera off, please. Okay, so this is the circuit for this piezoresistive sensor and frequency output. Nothing. So we have instrumental amplifier. This one, we have integrator here. We have zero crossing detector here, and the multi-vibrator. And this is the switch. For this piezoresistor, Rn is 114K ohm, and delta R from 0 to 8 ohm. So this is plus delta R, this is minus delta R. Then we can use SPICE to simulate this circuit behavior. Then here's the result. Delta R increase and delta F decrease. Remember, when you derive the equation, so this is sensitivity. So delta F divided by delta R. There's a minus sign here. So it means delta R increase, delta F must decrease. Then for the multi-vibrator, the function of multi-vibrator is to provide a fixed period vibration signal. Yes. See, for this multi-vibrator, we need to have a fixed time period vibration. Whenever there's a zero crossing, we trigger this multi-vibrator to vibrate with fixed frequency. So see, every time we have zero crossing, trigger, zero crossing, trigger, zero crossing, trigger, zero crossing, trigger. So this multi-vibrator can provide this fixed frequency vibration, fixed time period vibration. Then I will ask Bo Chen to explain the operational principle of this multi-vibrator.
Original, we now have the input is 0, and original this is 0. Okay, so this is NOR gate. So NOR gate 0, 0 output is 1, and 1 and 1, and this is 1 also. So this is 0. So we can check the first 状态first state, and then we have the input is 1 pulse. So 1, 0. So this will become to 0, and 1 and 0. So this will charge, and when this charge, and this will.
Okay, keep going.
So this will charge from 0 to VTH inverter. Is across 0. VDD divided by 2, and when it cross the VDD divided by 2, it will become to original state. When it is 0 and this is 1, so this come back is 1, so it will keep to charge.
Okay, thank you. Probably you won't understand, but it's fine. The operation can be explained by this timing diagram. So whenever we have the input, this pulse, then this is the output of multi-vibrator. It will vibrate with fixed time period. So it's okay if you cannot follow that digital circuit. There's a NOR gate and inverter. In the future, if you need it, you can learn it in detail. Then so I asked Bo Chen to run the SPICE simulation for this circuit. Then he could get the result of this one. But how can we plot this one? Then let's take a look at this bind cycle.m. So after the execution of the HSPICE, you will get this result. The first column is time, input pulse, and the second column is the VM1, third column VP1. time. First column is time, second column is input, and third column is VM1. The fourth column is the output. So we want to plot time versus this input versus time, and output versus time. So we want to use the column data to plot our result. But the first thing is, the first two lines are not data. We need to ignore the first two lines and read in all the other lines. And because the first column, there are some numbers. They are the same. So if we take a look at the output format, see here, 2.421 times to 10 to minus fifths, 2.421, 10 to minus fifths, they are the same. So this is not acceptable because we can only have one time point. We cannot have two time points at the same time. Then we cannot plot. So we need to check this condition and remove the repeated numbers. So let's see how we can do that in MATLAB. And I put format long here because in MATLAB we can detect more digits of affected number. So we set the format into long format. So we read in this data file, but we want to remove the first two lines. They are not the data we need. So we have this command. And after that, we read the rest lines into this format because we just need column 1, 2, 3, 4. The other columns, we don't need it. So we use this command to ignore the other columns. Okay, so we use text scan. Then whenever we open a file, if we don't need it anymore, remember to close it. And because when you use text scan to read in this data, it's a cell, it's not a matrix. So we need to convert this cell to matrix. So now this one is the matrix. We can use MATLAB to operate on this matrix. So for this matrix, column 1, column 2, column 3, column 4, we assign 4 variables for the 4 columns. Then we create a table. The reason we create a table is to remove the repeated time numbers. So we create a table. We use column 1, 2, 3, 4 to create a table. In order to remove the column 1 repeated numbers, we use table command. This is table name and the first column of this table. Unique means we want to remove the repeated numbers in column 1. So after we do this, we can create this unique matrix. Then we can turn this table into array again. Remember, matrix operation, we need to use matrix in MATLAB, no table and no cell. So now we turn this one into array, so we can operate on this one. Now this one means column 1, 2, 3, 4, and no repeated numbers. Okay, so we are ready to plot result. So, okay, we assign column 1 into time, and column 2 input into G. For some data, there is a trend. it may keep going down. So we want to remove the trend. We just want to take the variation of the numbers. So we remove trend, the trend. So we get this data. Usually we don't need to do that, just to teach you one function. Okay, then we do, find peaks. Remember, we don't know the period when we read in the data. Bo-Chuan may know he assigned the period to run his pulse, but I don't know. So I need to find out the period by myself. So I did this. So this is the data, the pulse, and the second is the time. So I want to find peaks. Because the pulse, we have peaks. So we can, if we find the peaks, and those two peaks, we can peak 1, time 1, T1, peak 2, T2. Then T2 minus T1 is the period. So we can do that. Then we can find peaks. Then because we have many cycles, we need to find the average number of those cycles. Then I do this mean, then DIF locations to find the average period, mean cycle. Okay, then after that we find the period by running this. If you want to know the detail, you need to go to the MATLAB to check each function. Then you will know more detail about this file. Okay, mean cycle is the period. So we find the period. Then we can plot the result. Okay, figure 1 is the pulse signal. So figure 1, we can ignore this one. Let's go to figure 3. Okay, figure 3, I create 3 subplot. The first 3 column, 3 row, 1 column, 3 row, 1 column. So for this figure, I have 3 subfigures. The first one, this is time, but I change time to microsecond. So times 1e6, and this is the pulse signal. But remember, it's a long, a lot of numbers. So we just want to plot several periods. So we can do this. We assign the axis. This is x coordinate, x minimum, x maximum. So from the cycle, the second one, to the number 10, I plot 8 cycles. And for y coordinate, I don't care. I just care about the x minimum and x maximum. So this is for time. So this is for V in, pulse V in. And the output signal is the fourth column of the data B, and this is microsecond. Then this is time, microsecond, and voltage, volt. So again, from second period to 10th period. Because for the first period is kind of transient, it's weird. So we take the second period to the 10th period. Then we can plot those figures here. So we can plot this one. So you should learn how to use this one. Then you don't need to manually to pick the period and try to cut this one and add this one to that one. So do things, use MATLAB to do smart things, okay? Any problem today? Leo? Okay, now do you know what's the Okay, Leo, let me ask you. What's the relation between F and capital T? F and T. Yes, reciprocal. Okay, so any other problem? Frank, any problem with these derivations? Okay, so that's all for today. And cameraman, please